Hello there, everybody. And like I said, by the end of the month, I'd have an update video on my alarm clock, and here it is, the whole shebang. Anyway, so first thing I'm going to talk about is the op-amp circuit that we were using before. This time, we took the exact same circuit that I had originally, which was on the breadboard in the last video, and we made a PCB. So we printed a printed circuit board, so we could solder on all the components together and have like one solid piece, so it actually would be nice. And besides that, actually everything's the same. It's just on a PCB. The only thing that's different is that the potentiometer we use is a different value because the other one was more prone to making more noise. So we made that so we could cut down on the noise level that was given. And actually right now, oh, okay, let's turn that off. Sorry, it seems like the speaker can actually pick up on my phone's noise, which is signals, which is really awesome in my opinion. Not good, but awesome. We also added a switch, which would cut off the voltage from this 9-volt battery that will run this entire system. So just like this, just basically the on and off switch of this entire speaker op-amp combo. The STM32 board is still the same, it's just with a lot more wires coming out of it. Each wire doing several different things. And there's the display right there. Underneath all of this just mess and chaos. I've also added 4 buttons in order to perform different functions with the new alarm. So I guess let me actually show what the alarm does. So first let's restart the alarm. So right now it's in a 0 state where it won't do anything until you press button 1. So when you click it, it will show the current time. While granted this is not actual current time, you need to set the current time to what value you want it to be. Now according to this, it's 1 p.m., this dot signifying p.m. And sorry the letters aren't the most easy to see. There's not a lot I can do about that because I didn't give a VCC voltage across to the anodes of the diodes, because I'm just running the voltage straight from the pins. So when the pins are on high, which is about 3 volts, it'll just go right through a resistor and then into the diode. But that's actually playing real time. If you press the button again, it now says 1:01 a.m. This signifies that it's in the alarm state. Just switching between this button switches between the real time and the alarm time. As you saw there, it now says 1:01 p.m., meaning it's actually keeping track of time. Although the problem is it's not actually 1 minute. Due to the fact that the code I've written is not the most optimized, it drives a lot longer. So it's more probably around 1:30 to actually create a minute. That's just optimizing code though, so personally on my skill level there's not a lot I can do about that. It is what it is. So actually let's restart the board again and just go back from the beginning state. So now I can also, now we're back at the current time, and now I'm going to increment the hours by pressing button 2. 1, 2, 9, 10, 11, and when we reach 12, it goes, the little dot's gone now. The little dot's gone. So now it's 12 a.m. We switch between that. Let's bring it back to let's go 3. And now if I press button 3, the third button on this, it will increment the minutes. And if you hold it, it'll just go right through. Now I'll just keep going all the way. I have it set up so when you reach the end at 59, it won't roll over. It'll just stay at 3. The minutes are, in a sense, when you're in the manual control with the buttons, do not affect the hours. So the minutes and hours, in a sense, are not connected in a way. But although in the RTC, the real-time clock, they are actually connected, so in the minutes. So if I set this to 3:59 and let 1 minute pass, it will actually roll over to 4 o'clock. But that's just going to be waiting, so we'll worry about that in a bit. And button 4, well, that's button 4 for right now when we're on the display state will actually turn off the music when it starts playing, because since we have a current time and an alarm time, when the alarm goes, oh, there looks 4 now, it rolls over like perfect. So anyway, like I was saying, was when the real time and the alarm time are equal, which they are not, 1:01 a.m. and 4 a.m., the alarm will go off and it'll play the music file off my flash drive again, and it will come right out onto the speaker. So let's actually do that right now. So since my alarm is set to 1:01 a.m., we'll just change my real time. Just need to alternate between that. Alright, so we'll just wait 1 minute on that. Actually I'll explain that later. For right now, we'll just unfortunately have to play the waiting game, which is really unfortunate. The thing is, the code is set so I cannot alternate the minutes. So if I was to make this 1:01 a.m. also, so then they would match up, like if I just were to increment that, the alarm would not go off. Because as a user, if you were trying to set the alarm to a current time, it would be really annoying if, as you were changing the time, the alarm just went off. So I have it set so only when the clock rolls over will music start to play. That way the user will not be like annoyed, because that would, honestly, I don't know about you, that would actually drive me insane. Because every time I changed the clock and it was conveniently same time. Oh, and now it's 1:01. I'll stop rambling with that. So since we see all the flashing lights there, that means it's reading the audio file off my flash drive, and it's sending the signal into my op amp. Well, I already turned the op amp off, so if I turn it back on and adjust the potentiometer. Oh, that's actually, sorry. The signal pin fell out. These aren't soldered onto the board due to the fact that mine keeps... Wow, that was loud. But yeah, this would start to play. We just have some music playing. Alright, so I don't have a lot more time because I'm running out of film space on my phone, so I set it up back so we're now playing audio again off the speaker. So we press button 4, music stops playing, we're all good. We set off the alarm. And then you can just reset to another time. Now then, there's also one more function my alarm has, where if you're in display mode, alarm mode, so now we're trying to change the alarm, if you're in clock mode, it shuts off the alarm. If you're in alarm mode, oh, what? There we go. It'll start to play the audio again. And then you press it again, stops it. So that will always stop the song. That way, if you're saying you're alarmed and you want to have custom music, you can put on any song you want, but you want to just like test it to make sure it works. You would just go onto the alarm and just like press the button and see how it sounds. Which is great because then you can like set your potentiometer, get what volume you want, and then make sure like your system's on or whatever. So that's my entire alarm clock. There's also one more piece here that was not been able to get into the project, was the faceplate. This was 3D printed by my partner, Shajad. Really good job, honestly. Like, I'm actually really impressed by this. Like, the buttons will fit perfectly right in here, and the display will fit perfectly in here. It's just that some of the pieces weren't able to get 3D printed in time for the project, so we had to go with this. It wasn't a big issue. It was just for extra marks, really. So just to make it look fancy, because honestly, like, you want a fancy alarm clock if you're giving it to the people. And I gave it the name Chronos for time. I'm actually kind of proud of that one. Anyway, so that's everything. Running out of space on my phone. I'll see you guys in the next video.